Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, we have completed the biology section. So today we are going to from today we are going to see the remaining chapters in the physics section. So 10 chapters remaining, 11 chapters remaining. Then we will go to module 4, inshallah. Okay, now today we will see the 10 chapter force and motion. So in the previous lesson, Afash taught you about the motion of body and how the motion can be uniform or non-uniform. If you don't remember all this, then go to ninth lesson and read about it, and you can remember whatever he taught you. And you might have also seen a body at rest. If the body is at rest, body means anything, okay, any object. It can be brought to motion, and also if there is a moving body or moving object, it can be brought to rest, okay, by applying force. That is there. So now we'll go into the lesson. First one is force and motion. So there is an example. See, there is a surface, and if you place like a flat surface is there, and you keep a ball on there, okay, a round ball, okay. It's not exactly round, but let's assume that it's round, okay. So there's a ball. If you keep it on a flat surface, there is this like completely flat, okay. So the ball, it won't move until we disturb it, okay. It will move only either we push it or we pull it, okay. So it will move only if we push or pull it. So the push or pull acting on an object is what is known as force, okay, is what is known as force. So that you have to remember. Next one is the balanced and unbalanced force. So have you seen a game of tug of war like this? Two group of people on each side, they have a tug and they pull, okay. So each team, they pull with equal force, okay. If there is an equal force between the two of this team, okay, so what happens is that they do not move. No, both of them will be pulling, but there will not be any move. So that is balanced force. But if one of the team applies greater force, more force, then they'll be able to pull the other team towards their side. So in this case, the forces are unbalanced. That you have to remember. So this is what is called as balanced and unbalanced forces. So they have given more example. I mean one more example by this method. Then activity you can read about it inshallah. And the next one is Newton's law of motion. So we will see Newton's law of motion. Before that, we will see what is inertia. If you see what is inertia, if we shake a tree, branches of a tree vigorously, what happens is that the leaves and the fruits get detached. They get detached, and also when you beat a carpet, if there is a carpet and if you beat with a stick, you will see the dust particles get detached from the carpet. Okay, do you know what? The answer to all these questions is inertia. So we'll see what is inertia. We'll have an example here. There is a table. Okay, you keep a paper like this, paper out of it, and here like this, and you keep a glass tumbler with water in it like this. If you pull the paper suddenly, what will happen is that the glass won't uh, fall down, it will just be like that. So this is due to the inertia. So what you observe, you will find the gas remains in its position. So the inertia of the glass prevents it from moving the water paper. So inertia, we will see. So now you can understand that inertia is a tendency of objects to stay at rest. So the tendency of the objects to stay at rest, to stay at rest or to keep moving with the velocity. So it is to stay at rest or it does not or keep moving with the same velocity. So even if you apply force, it has some tendency. Okay. So they have given other examples as well. You can read about it here. The next one is inertia and mass. Now we have learned about the inertia, that is, it offers some resistance, that tendency to be at rest. So the object offers some resistance to change its state of motion. So if you pull the paper, it should move, but it has a tendency, it has some resistance that does not let it move along with the paper. Okay. There is another example. If you push an empty box on a smooth surface, there is a smooth surface, you keep an empty box. If you push it like this, if you apply the force here, you push it, you can push the same, easily. But if it's full of books, then what will happen is that you will have to apply more force. So why is that? Because the mass has increased. That is the reason. The mass has increased. So all the objects do not resist a change in a state of rest or motion equally. So not all the objects, they do not resist a change in the state of motion or rest equally. The massive objects, the objects containing more mass, they resist more. They resist more than the lighter ones. Because if you have any books, then they resist more because of the mass. Because of the mass. We can say that mass is a measure of inertia. So mass is related to inertia. So now we will see Newton's first law of motion. We learned that an object offers resistance to change in its state of motion. If an object is there, it offers a resistance until you push it. Okay. So Newton studied this in detail and he presented his findings in the form of three fundamental laws. Three fundamental laws he proposed that govern the motion of objects. That is related to the motion of objects, the moving of objects. So the first law of motion states that every body continues in its state of rest. For example, there is a body, there is the object. Every body continues in its state of rest or of uniform motion in a straight line, okay, until it is compelled by some unbalanced force to change the state. Until it is compelled by some unbalanced force to change the state. You have to memorize this. Every body continues in a state of rest or uniform motion in a straight line until unless it is compelled by some unbalanced force to change the data. Unbalanced force from here. Okay. So the Newton's first law of motion tells us that all bodies resist a change. They resist a change in the state of motion. So we know that this property of bodies is called as inertia, as we saw earlier. So that's why Newton's first law of motion is also known as the law of inertia. That you have to remember. So first law of motion has many applications in our daily life. If you're in a bus, if you're in a bus standing and suddenly if the bus moves, what happens? You move back, okay? Or if the bus is moving and suddenly there is a brake, you move front. So these are all due to the inertia. So the feet of the passengers are in contact with the bus. So they have an inertia here. So when the bus starts suddenly, The feet start moving in the bus, but the upper part of the passengers tries to remain at rest due to inertia and tends to fall in the backward direction. Okay, so this is an example for what if the moving bus suddenly stops. The next is momentum. The earlier section we saw about that the force is required to stop a moving body, and it depends upon its mass. So there is a moving body and you need a force to stop a moving body, but it depends upon mass. How much mass? If it is more mass, then you have to apply more force. If it's less, then you have to apply less force to stop that. Now let's say that there is two balls, okay, two balls of same mass, no difference in their mass. They are moving with different velocity. One is moving with this velocity, another one with a higher velocity. So which ball do you need more force to stop? This one, obviously, because it's moving with more velocity. So the force required to stop body also depends upon its velocity, not just the mass, because here the mass is equal, but the velocity also is related. So the force required to stop a body also depend upon its velocity. So they have given another example here. You can read about it. And from these observations, we can understand that an impact produced by the object depends upon their mass and velocity. So mass is there, and next one is the velocity is also there. So these two quantities help us to define a new quantity called as momentum. So what is momentum? So momentum is denoted by p, small p. It's the momentum of a moving body is defined as the product of its mass and velocity. So not just mass or not just velocity, but we product it both together. So momentum is equal to mass into velocity. It's very important, you have to remember. Now how to find the unit of it? So the SI unit of momentum is kilogram meter per second. How? See, momentum is there. How to find the unit? The first one is mass. The unit of mass is kilogram. SI unit, kilogram. And what is the unit of velocity? Velocity is meter per second. Meter per second. So if the second comes out, it becomes second power minus 1. Okay. So now momentum is equal to kg meter per second. Okay. So that is the SI unit of momentum. So the momentum has both magnitude and direction. Magnitude means magnitude and direction. So its direction is same as that of the velocity. The way the velocity comes, that is the same direction. That you have to remember. The next is Newton's second law of motion. According to Newton's first law of motion, the application of an unbalanced force, there is an object, application of an unbalanced force brings a change in the velocity of an object, brings a change in the velocity of an object. Thus, the force can produce a change of momentum. So, the force, this you are applying some force, it can produce a change of momentum. How the momentum changes? So, the second law of motion, Newton's second law of motion establishes a relationship between force and change in momentum. Force and the change in momentum. So, what does the second law state? Second law of motion states that rate of change of momentum of a body is directly proportional to the force acting on it and takes place in the same direction as the force. So the rate of change of the momentum, there is a body. The rate of the change of the momentum of this body is directly proportional, not inversely proportional, but directly proportional to the force acting on it and also in the same direction of the force. If the force is applied like this, then it is directly proportional to this one. So the Newton's second law of motion also gives a relation between the force and the acceleration. So let us now derive this relationship, or okay. Suppose the velocity of an object of mass m. So there is an object and it is, let's say it is moving, and its mass we are denoting this as m, and uh, the velocity changes from the object velocity changes. So initial velocity we are keeping as u, and the change in velocity is v within a time of t. Let's say you are 3 seconds. In the first second, in the beginning, the velocity is u, and in the third second, the velocity is v. So this is an example I am giving. So the 3 second will be the t. Now to change the velocity, we need some force. So the force is denoted as F. The constant force is F. So now we will derive the equation. So the magnitude of initial momentum will be, let's say P is the momentum, as we told earlier. So now we are finding the initial momentum. So we say 1, P1 equal to m, the mass, and the velocity is u here, because that is the initial velocity. If it is the final momentum, then P2, then m, the same mass, but the velocity is different. So mv. Okay. So how to find out the change in the momentum in time? So we say t equal to P2 minus P1. Here they have given P2 minus P1. So the rate of the change of momentum, how to find that? To find the rate by the time. The t will go here. So P2 minus P1 by 2 is the rate of the change of momentum. So according to the second law of motion, the magnitude of force F is directly proportional to this one, P2 minus P1 by T. Now we will have something called as constant of proportionality. This is some constant. It is denoted by K to equal it. So equal to K P2 minus P1 by T. Okay. So this is the magnitude of force. So now we will substitute the values here. P1 is equal to mu, P2 is equal to mv. So let's substitute this. P2 mv, P1 mu by T. So m is there in both variables. So it will be taken as common, Km T minus u by T. So now v minus u by T is the rate of the change of velocity. Yes, because this is the final velocity and u is the initial velocity by time. So we know that the rate of change of velocity is the acceleration A. The rate of change of velocity is the acceleration A. So now v minus u by t will become A. So the equation will become F is equal to K M, and this will become A. So it will be KMA. So now we choose the unit of the force in such a manner that the value of K becomes 1. So we can define as 1 unit of force. This for this 1 unit of force, and which produces acceleration of 1 meter per second square with 1 kg mass. So let's substitute this here. 1 unit of force, 1 kg, 1 meter second power minus 2, and so this k will become 1. Okay. So if the k becomes 1, it will become F is equal to ma. So the unit of force is called Newton and its symbol is N. So this you have to remember. The unit of force is called Newton and its symbol is N. So a force of 1 Newton will produce an acceleration of 1 meter per meter by second square on an object of 1 kg. This also you have to remember. A force of 1 Newton will produce 1 meter second power minus 2 acceleration with an object of mass 1 kg. So here They have given an example. Let's say they have there is a there is an object of mass of 100 gram is kept on your palm. So how much force you feel on your palm? So that you have to calculate. So we have this formula: force is equal to ma, mass into acceleration. Here m is equal to 1 by 10 kg. That is 1 kg is 1000 grams, right? So uh, now to represent 100 grams, you have to write 1 by 100, 1 by 10 kg. Okay, 1 by 10 kg is 100 grams. 1 by 10 kg and A is equal to 10 uh, meter second power minus 2. Approximately they have taken it. Okay, so now 1 by 10 kg into 10 meter second power minus 2 is 10, 10 will get cancelled. So the F will be, force will be 1. The unit of force is Newton, 1 Newton. So you can understand here the force exerted by a mass of 10 grams on your palm is approximately equal to 1 Newton. So here they have given some example for the second law of motion. They have given some example for the second law of motion from our daily life. So you can read about it here. You can read about it here. All these examples they have given is all due to the momentum. And also based on the formula we have force equal to mass into acceleration. We apply the formula based on the information given here and find out the asked values. So for example here they have asked about the acceleration. They have asked about the acceleration. They have given the force and they have given the mass. So now they have given the force, that is 15. So you can write as 15 equal to, what is the mass they have given, 3. But now we do not know the acceleration. So what you do? This 15 will go here. So this 3 will go here. 15 by 3. 15 by 3 is 5. So this is the acceleration. So A is equal to 5. And what is the unit of acceleration? Meter second power minus 2. So all these units you have to remember. Whatever units we saw, write it in a notebook. Unit of acceleration, meter second power minus 2. Unit of force, Newton N. Unit of mass, kg. Okay, unit of velocity, meter by second or meter second power minus 1. So like that you have to write it down, keep it, so that you can study easily, inshallah. And also there is another problem. You can do it and write it down in your notes. So the Newton's third law of motion we will see in the next lesson, inshallah. So dear students, I know this physics is little difficult. You have to understand many things, but try your best. Listen to the lessons multiple times. If you have any doubts, you can message me. I will clarify, inshallah. Okay, see you all. Assalamu alaikum wa rahmatullahi wa barakatuh.